All right. So number one here, this is 3.1 practice problems part 2. In a game of tug of war, the rope is pulled by a force of 163 newtons to the right and a force of 119 newtons to the left. What is the magnitude and direction of the net force on the rope? To the right. And let's just subtract the 2. So it's just going to be 163 newtons minus 118 newtons, 44 newtons, and the direction. Yep. Right. I'm assuming there are no questions on that one.
Every time I see N, I think.
So, next one says, find the acceleration of the two blocks if the coefficient of friction is 0.38. Mass of block 1 is 16 kilograms, mass of block 2 is 13 kilograms. Alright, so, yes. So how fast are they moving is what I'm looking for. Okay, so which direction are they going to be moving if they're moving?
To the right. It depends.
Yep.
Wouldn't it?
There's no other forces. The one that's, it's like a pulley. So if they, you can think about a pulley right there, and they're attached by a string. So they have to be moving down. Does that make sense to everybody?
Wait, what
Both
is
of them are going to be.
one? It's like a pulley though. If one gets pulled in.
Yeah, wait.
Yeah.
I thought that one on top being pulled down.
So
Yeah, it's not being pulled down. The one on the, like on the table is being pulled to the right because that one's falling down. So like,
Attached by a rope and one's falling off, right?
yep. So everybody understand the diagram?
Well, it's still smaller, but it's like pulling it down.
What?
Like is the set
It's
that
still
one-
moving it down, yes.
Oh, it's still going. Is that one moving down though, or is it?
Both blocks, so M2 is moving down, M1 is moving to the right.
Okay.
So let me get this straight. There's a rope.
All right. So we want to start with here is our total force equation. What are the forces acting on the two blocks?
Gravity.
Gravity. Which block? The gravity of which block is causing it to move?
M2.
M2. So we're going to say Fg of block 2. And what are the forces there? Friction.
On M1.
On M1, are we going to add or subtract that? Subtract. So force of friction on 1. And there are no other forces that are causing it to move. There's like, on this one, there's a gravity's pulling it down and normal force is pushing it up, but those don't affect it moving side to side. That makes sense? And so we're going to say total force equals MA. What's our mass going to be? 2 together. I'm just going to write it out so you guys can see it. M1 plus M2 times A equals force of gravity. What's the equation for force of gravity? Mg. So it's going to be mass of 2 times G minus, what's the equation for force of friction? Mu Fn. And what's Fn equal to? Fg. And what's Fg equal to? Mg. So it's going to be M1 times G. Any questions on either of those two equations?
Why is it M1 plus M2 times A?
Because it's the mass of both blocks. Fn, so we said Fn equals Fg for this one because those two forces are going to be equal. This is Fg, Fn, and Fg equals Mg. Alright, that's always the case on flat surfaces. If there's an angle involved, it's going to be a little different. So now I've got 16, oops, plus 13 times A equals 13 times 9.8 minus 0.38 times 16 times 9.8. $2.34. All right. Any questions on that one? Does everybody understand how? There's another block one. Everybody understand how we got from this equation to this equation?
Yes.
Yes. Okay. Everybody understand how we just got this equation?
So force is mass times acceleration.
Force is mass times acceleration. Total force is always just going to be ma. Tatiana? What? So on a flat surface, we got a block. Fg is pulling it down, and the normal force is the same magnitude pushing up on it.
Why do they both the same acceleration?
Because they're connected. So a block slides on a frictionless surface. What is the tension in the rope? So when we talk about the tension in the rope, we're talking about how hard this rope is pulling both blocks. It's going to be pulling both of them equally.
13 kilograms.
So first thing we need to find is the acceleration of both blocks, and then we're going to find either use M1 or M2 to find the tension in the rope. So what's our total force acting on them in this case? Just Fg2, right? Because there's no friction. So we're going to say M1 plus M2 times A equals M2 times G, and we get 15 plus 13 times A equals 13 times 9.8. I'm more than happy to slow down. I apologize. I get so excited about physics. Alright, so there's last time we had a force of friction. This time we don't. So the only force acting on these that's causing them to slide is that Fg2 pulling it down.
It just doesn't make sense that there'd be no friction. It's sliding up.
It's hypothetical.
So I think it's a poor question.
Right.
There's no frictionless surface.
Okay, I
The frictionless surface.
Connor, stop.
I get confused, like when you say FT, because that could be for the force of tension.
Force of tension we're going to call F10
Oh, okay. There we go.
to keep them straight.
Okay. Thank you.
Right. Anybody got the acceleration?
Yes.
4.5.
5.
5.55. Alright. Okay.
Keep your sick things.
Any questions on how I find the acceleration? Okay. So now, I'm going to do this in red. We're just going to look at box 2. Because we can't find the tension in the rope looking at both the whole thing. For this, we looked at the whole thing.
Okay.
So we just got to look at one of the boxes to find the tension in the rope.
We could do either one.
We could do either one.
Okay.
Alright. So we're going to say total force on block 2 is going to equal what? What are the two forces?
The tension and
Gravity. Alright. So it's moving down. So we'll make Fg2 positive. And what are we going to do to the tension force then? Negative. The tension's pulling up on it like that. So minus F10.
Wait, how do you know what to subtract?
So we know the whole thing's moving this way, right? So any force that's going with it moving is going to be positive. Any force that's keeping it from moving is going to be negative. Yep. So we've got M2 times A equals M2 times G minus force of tension. So we get 13 times 4.55 equals 13 times 9.8 minus F10.
No parts really make up F10, right? F10 is just like,
It's just the force, so you can't do like MA or anything like that with it.
just checking. 68.
Right. Any questions on how we get any part of that? So when you're looking for like the tension or the force between two blocks, it's going to have to be look at the whole thing and then look at the individual part. All right. Okay, go on to the next one. Number 4 says, a mass is being held up by two metal plates. Coefficient of friction between the plates and the mass is 0.41. What is the minimum force required to hold up the mass? All right. So what forces are going to be acting on this block? Gravity's pulling it down, and friction's pulling it up, or holding it up. Yep. So if you're pushing it together, the friction with the sides is what is holding it up. All right. So Ft is not moving, so we can choose either direction as positive. So let's choose Fg as positive just to make life slightly easier. So it's going to be force of gravity minus force of friction. Does that make sense to everybody?
When it's both, you just pick one.
Yeah, when it's like, in this case it's not moving, so we can just pick one as up or down. And how many forces of friction are there going to be? 2. There's going to be one on this side and one on that side. So we probably should put 2F, and then we can just solve for one of those. Alright, so Ft is equal to Ma. Fg is equal to mg minus 2. Force of friction is mu. And what's Fn going to equal in this case? Nope. Not mg. Because we're like, remember the force the normal force for force of friction is the force that the surfaces are being pushed together with. So how hard are the surfaces being pushed together? No.
It's gonna be the sum of the.
It's just going to be one of those forces. So it's that force right there. That's what goes right there.
What is FN?
Fn is the force that's pushing the two surfaces together.
So, but in general, FN would be like any like extra force that you push in
Yes.
besides gravity and.
So Fn is normally, when it's equal to gravity, it's just because it's on a flat surface, and gravity is what's pushing the surfaces together.
Oh, okay.
But in this case, we have a force pushing the surfaces together instead of gravity. And it's not 2F, which is something reasonable to think, because for each of these, like if there was, think about this, if there was just a wall here instead of another force, then it would just be F and nothing would change. So if you hold something against the wall like this, the eraser. If you hold the eraser against the wall, all that matters is the force I'm pushing with. But if I do this, it's the same thing as a wall. Does that kind of make sense? So we just use 1F. That force is not multiplied by 2. Well, there's 2 frictions, but the force, the normal force, is not multiplied by 2. Everybody kind of understand that? Okay. So we've got M is 20 and A is 0. Oops. It's being held up, so we're assuming it's not moving. So 20, so just put in a 0 there. It's 20 times 9.8 minus 2 times 0.41 times F. It's going to be a little over 200, I think.
240. Well, 239.
Any questions on that one?
On how is like that? Are you always gonna know that it's not moving? Like it's gonna tell you.
Yeah, I guess I should have made it more clear, but you can always ask on something like that if you're not sure if it's moving or not, and I'll let you know. That's a good question to ask during tests.